and the remove at also require a little bit of massaging. If we happen to be inserting at the end of the list, then we have a little bit of a problem. So when we do that, we need to accommodate our tail node. And the way we do this is to check for whether or not we're inserting at the end. And when we get there, we want to make sure that we accommodate the temp item. And so here's what we want to do. I want you to remember that we move to position. So we're setting our temp to point at the next node. If temp ever becomes null, then we've gone off the end of the list. This was what we learned when we did the insert at. The moment we know that we are at a node and we've reached the position -1, we can create our new node. And then the way we weave it into place is we set new node next equal to temp next, and temp next equal to new node. This is the classic weave of the thing in place. But there's one last caveat that we need to consider. So I'm going to stop the share here, and I'm going to draw this to make it a little bit clearer. So let's pretend that we have inserted a couple of things here. All right, I'm trying to stay below this. And our tail reference is looking at the last node. So this is the situation we're in right now. If we insert anywhere other than the tail, we're okay as far as the tail is concerned. If we're inserting at the head, well, the insert at head will take care of that. So we're not worried about that. But we have to worry about detecting whether or not we're inserting at the end. The nice thing about the insert at method, if it doesn't have a tail node, then inserting at the end is not a problem, right? We have this new node, right? And remember, we use it to create a new node that's set to null. We have temp, which we have progressed all the way to point at the one before. Remember, temp is holding the one in front of the one we're inserting. Since we're inserting at the rear, okay, what we want is temp next to point at the new node. Well, and that happens in our code, right? I'll switch back and show you that line. Now, if temp next is pointing at our new node, then we're done if we don't have a tail reference. But if we have a tail reference, we have one situation that is potentially problematic, and that can be discovered very easily. If tail and temp are looking at the same node, then we're inserting at the tail of the list. So if I can detect that tail is equal to temp, then I know that I'm adding on to the end of the list. So I need to add one small statement setting tail, right, equal to new node. And now my list is intact. It's complete. So let me start the share back up. All right. And so here's that moment where I declare my new node and I set new node next equal to temp next, which would be null if I was doing this on the end of the list. Then I set temp next equal to new node, setting the previous node, the one I moved to point at the new node. Now, once again, at the very end, I have to do a check. If my tail reference is looking at temp, then I just add it on to the end of the list, and I need to set tail equal to new node, or tail equal to tail next, or tail equal to temp next, because all three of those references are valid in this situation. It's kind of crazy. So new node is holding it in place, temp next, and tail next are all actually storing the location of the brand new node. And so by doing this, I've attached the pointer to the end of the list, and by inserting, I am at the tail. And that's it. So it's just this little piece of work at the very end, modifying the tail reference when needed. Now, when I do a remove at, right, I'm looking over here every now and then because I want to make sure that I'm not forgetting something. So insert at, and when I do the remove at, so here's the deal with the remove at. If I get to the remove part and I remove the last node, then the tail reference will be pointing into space. Technically, it will be pointing at a node that isn't in the list anymore. And what I want to do is to back that node up. So let me stop the share again and describe this situation a little bit more clearly. So we just did the insert at the end, the new and the temp references. Those are in the stack frame, so they'll go away when the stack frame is removed, when the method ends. Just to clean this up and make it a little nicer, I'm going to erase a couple of nodes. Well, I'm going to erase this just because it's kind of annoying to have it sitting there in a slightly ugly way. And so now we'll do this, right? And if we remember from our remove at, the remove at moves the temp and it moves it to the node before the one we want to remove. So if it so happens that we are removing the last node, well, we're going to set temp next, right, equal to temp next next, which is this, which is null. This will sever the link to the last node, leaving us like this. When we're like this, our tail is now referencing a node that isn't in the list, and we need to back it up one. Well, how do we do that? Well, all we have to do is check using temp. If temp next is null, then we remove the last node because the last node had a next of null as well. So when this got set to here, it became null, severing the link, but we can check to see if that link was severed by checking temp next. If temp next is equal to null, then we need to back tail up by setting tail equal to temp, because temp is holding this node. So we would set tail equal to temp. And then our method would end. When our method ends, the garbage collector will take care of that. Temp is in a stack frame. It'll go away. And now our tail node is backed up one. Okay? So again, a small piece of code to get this done. In our remove at, right, when we've done this bit of work, if temp.next is equal to null, then we set tail equal to temp to bump the tail reference up. Okay, and that's it. Okay, now we've already noted that if we remove at the head, if it's position 0, we're going to do remove at head. Well, I didn't change that one yet. So let's do that. The remove at head is pretty straightforward. Oh no, we did that already. Sorry, I forgot that we had done that already. So that one we did do, and we've got that taken care of. So now we should be able to insert at and remove at the head and the tail without any trouble. One method that I didn't notice in this particular list is one that I want to add to it right quick. And it's the getter for the head value and the tail value. We're going to do that. So public int get head value. This gets the value at the head of the list only. And here's what we're going to do. If this is an empty list, we have a serious problem. So I'm going to use an assert statement, and I'm going to assert that head is not equal to null. And if that's true, we will terminate the program. That's what the assert will do. I could also throw an exception. I don't really care which way you do that. I couldn't really do an if because I have to return an int. And then I will simply return head dot data, right? Because I can do that. And now I'll do the same with the tail. One method that we did not talk about is the get method, where you get a value from a node given a position. We didn't have time to do that. There are so many different methods on linked lists and so many different variants. So I'll just do this. Change it to tail and tail. And this way, when we go through and test, we can insert some stuff and we can see whether it's working or not. And now I'm going to go to my linked list class driver, which I have been using to just test random stuff. And so let's do that again. Actually, why don't we leave this? But let's say my linked list class with tail. And just do that. And we did just have this set up to where it would do the inserts and removes. So let's run it and see if I broke anything, because I wrote 4 whole method, or I modified 4 whole methods. So the chances that I broke something is pretty high, I'm thinking. So let's just insert a 5, and let's do that at position 0. We'll try to do valid inserts all the time. So that's good. Let's insert a number 2 at position 1. And now let's insert a 0 at position 3. Well, oh, there isn't a position 3. I'm an idiot. So let's do a 0 at position 2. And let's do a 9 at position 0. And let's do a 1 at 4. And a 45 at 2. Whatever. Oh, I mean a 5. Guess I didn't hit the 4. 6 at 4. Whatever. An 8 at 0. And it's still doing. Okay, let's get this done with. Oh, I'm removing now. So notice the 9 is going away. And let's do position 3, which is the second 2. And then let's do 2, which is the remaining 2. Let's do the, if we go 1, 2, 3, 4, that's the last one. So it looks like it did okay. Remove from position 0. So I'm just popping them off right now. Position 2, position 1, position 0. And the list is empty, and this is designed to just keep going, whatever. It would go one more time. So anyway, so that's the idea. One thing that I'm going to do right quick is right after I do my print list, I'm going to do my list dot. print this. And oh shoot, my chat went down, in case you're asking.